The fifth question that we have is a very important question in which you learn how to find out the current and the charges in a circuit with capacitors. So what we need to first find out is the initial current in the circuit. The circuit has a battery of EMF, either a resistance R, this capacitor has capacitance C, and this capacitor has capacitance 2C, and there is a potential drop across this resistor, capacitor initially also, that is, it has some charge initially. This capacitor is uncharged initially, and we need to find out the initial current. So for finding out the initial current, you should think of finding out the potential difference across the resistor first. Let the potential at this point be equal to 0. The potential at this point will be equal to E. Since the potential drop across this cell has to be E. Now there is an increase in potential of 2E on going from this side to this side, therefore the potential at this point is equal to 3E. Now this capacitor is initially uncharged, and since there is a resistance in the circuit, therefore it will take some time for charge to develop in this capacitor, therefore it will take some time for potential difference to come across this capacitor. So just initially the potential difference across this capacitor will be 0. So the potential difference now across the resistance is 3E minus 0, that is equal to 3E, and therefore the current through the resistance will be equal to 3E upon R. Therefore the initial current in the circuit will be equal to 3E upon R. Now the second part is a really important part. We need to find out the charge on this plate of the capacitor 2C at any general time t. So for finding out this is a general method which we use most of the times. This is the battery with EMF E. This is a capacitor with capacitance C. There is a resistance over here, and we have a capacitor of capacitance 2C. Let charge Q develop on this plate of the capacitor after time t. This is t is equal to t. Let it be t naught at any general time t naught. So let the charge on this plate of the capacitor be Q. Therefore the charge on this plate of the capacitor will be minus Q. Now the initial charge on this plate of the capacitor was Q is equal to CV, that is equal to 2E into C, and this was minus 2E into C. Now after time t, look here carefully, a charge Q has developed on this plate. Now if we consider the system of this plate and this plate, they are isolated from the external system and they cannot exchange charge from the external system. Therefore the total charge of this system must be conserved, that is equal to 2EC. Therefore the charge on this plate now becomes 2EC minus Q, and therefore the charge on this plate will become Q minus 2EC, and let there be a current I in the circuit. So now to write an equation, we need an equation to solve the question. So the equation will be applying Kirchhoff voltage law in this loop. So when we apply Kirchhoff voltage law in this loop, what we will write is that the total potential increase is equal to total potential drop in one complete loop. So let us start from this point and we will return to this point. On going from here to here, there is a rise in potential of E. On going from here to here, let us assume this to be positive, this to be negative. There is again a potential increase of 2EC minus Q upon C, because potential drop is equal to Q upon C. On going from here to here, since the current, we have assumed current in this direction, therefore there is a potential drop. This is equal to minus IR, and again there is a potential drop equal to minus Q upon 2C. This minus sign is for potential drop. The potential drop's magnitude is equal to Q upon 2C because the capacitance of this capacitor was equal to 2C. Therefore this will equate to 0 by Kirchhoff voltage law. Now we get an equation in I and Q. Now we know that I is equal to dQ by dt. Since we have a current I over here, this current is directly responsible for changing the charge over here, that is accumulating charge on this plate, and therefore we write this as dQ by dt. Always remember, whenever this plate has plus Q and minus Q and you assume current like this, I will be equal to dQ by dt, and if you assume it opposite, that is minus Q and plus Q, and then you assume current in this direction, then I will be equal to minus dQ by dt. Be careful of this thing as to how you assume things. So now here I will be equal to dq by dt. Substituting I is equal to dq by dt over here, we get a differential equation in Q. On solving this, we get 3e minus 3q upon 2c. This is equal to r times dq upon dt. So now let us solve this differential equation. We get 6ec minus 3q upon 2c is equal to r times dq upon dt. This is t, this is c. Now this can be easily solved. We write dq upon 6ec minus 3q is equal to 2rc. 2rc will come here. That is 2rc into dq upon 6ec minus 3q is equal to dt. Integration of dt, will integrate this from t is equal to 0 to t is equal to t. The limit over here will be 0 to q, since the initial charge on this plate was equal to 0. On integrating this, we get minus 2rc upon 3 ln of 6ec minus 3q, limits from 0 to q. This is equal to t. Now on solving this, we get minus 2rc upon 3 ln of 6ec minus 3q upon 6ec. This is equal to t. So on solving this, we get 6ec minus 3q upon 6ec. This becomes equal to minus e raised to the power minus 3t upon 2rc. That is 1 minus 3q upon 6ec is equal to e raised to power minus 3t upon 2rc. 3q upon, that is q upon 2ec, is equal to 1 minus e raised to power minus 3t upon 2rc. Therefore we get the value of q as q is equal to 2ec times 1 minus e raised to the power minus 3t upon 2rc. And this is a final expression for the charge q on the plate 1 after time t.